All right, hello, I am Rochelle Smits-Seemann and presenting with Renan. And we're at Miro, and we're going to talk about the analytics engineering developer experience that we've set up here at Miro. And in true Miro fashion, I'm using Miro to present. So hopefully it works okay. So a little bit about Miro. I've been here about 2 years. Renan's been here about 2.5 years. And we work in the data products area. And what does that mean? So if you're not familiar with Miro at all, first of all, you're in Miro. So this is our headquarters. We have 2 buildings right now, this building and the one across the street, which hopefully you didn't go to, even though it says Miro on the front, and it's actually really pretty. But we're here, our global headquarters is here, engineering is here, and we have some offices around the globe, but our engineering is basically in Amsterdam. And we serve about 80 million total global users. 99%, these are like marketing stats, I pulled these from our website. 99% of Fortune 100 companies use Miro, and most of it is for live synchronous collaboration. That is our strength. So lots of people come together on a board or do a presentation. You collaborate. We use it for our retros, for sprint planning, for feedback on teams. It's great. I'm obviously a big proponent. I work here and I use it every day. So what does that mean for our data? The data at Miro is very interesting. It's the biggest data environment that I've worked in so far. And I'm not necessarily proud of this number, but it exists. We have over 3,000 DBT models. Maybe not something you should strive for, but it's there. We do have over 60 third-party integrations. So these, my colleagues are in charge of integrating data in and out of our data warehouse. And they manage a lot of third-party tools, marketing tools, sales tools, other business intelligence tools. So there's a lot of data movement. I checked and it's 217 terabytes is our largest table, and that's partly because we segment events into multiple physical tables in Snowflake because they're so big. And we reached 4 billion events daily. So these are users interacting on our platform, and we track basically click behavior and behavior on the board because we care about how users interact with each other, how they interact with our features, what they're doing so that we can build useful features. So what does our development experience look like? In the analytics domain, analytics engineering, we have over 80 contributors to our DBT repository. And this is basically the analytical transformations at Miro. We power all of the BI, all of the business insights. And we have over 50 monthly active contributors. So we have lots of people who are enabled and 50 people each month who do actively contribute to the repo. We merge over 300 PRs per month. You can see our graph over time. It looks pretty impressive at the end. I'm sure it'll come down. And then more importantly, so we're a company, we're at like 1,800 to 2,000 employees, and we have over 750 Looker monthly active users. So people at Miro look at data, and we're the team that kind of curates the transformations for that data. And we're responsible for making sure that the data is timely, it's accurate, it's updated, it's reliable. So that gives you a little bit of a heads up. And that's the preface of this talk. So my team is in charge of the developer experience for these contributors. So we work for, this is my team. We're about 10 data engineers and analytics engineers. We set up the repository, we manage Snowflake, we manage DBT, we manage the repository. And we serve about 50 analysts, product. So we have software engineers who are contributing because they're interested in how their features are being used. So now they can contribute to DBT models and then analyze how people are interacting with their features. And of course, we have data engineers who are doing the ingress, egress from Snowflake. They also do a bit on Databricks. But these are all the people that interact with the tools that my team curates, develops, and puts together. And this is the stack that we use currently. Well, this is a small part of it, but this is primarily where we work. So DBT is our main transformation engine. We use core, not cloud. Our developer experience is mainly in VS Code, so that's where local development happens for AEs. analytic engineers. We use GitHub for repository. All of our orchestration is via Airflow, and we recently migrated that to Kubernetes hosted instead of Amazon hosted. And most importantly on my team, we maintain the Data Hub data catalog. So this has been really important for democratizing data serving. So anyone can explore data, anyone can register their assets. You can see the quality of it, and they're expanding features like crazy, which has been awesome for our team. And Looker is our main BI tool, with Snowflake being our main warehouse and Databricks coming in a close second, maybe. Cool. And this is my last slide, and I'm going to hand it over to Renan, who knows a lot more about the technical stuff. But this is our overall workflow of data. So we use Airbyte and a few other custom-built tools to bring data into the warehouse. Just like Hannes's diagram, you've all seen something like this. It's pretty boring, but kind of nice to see the overview. And then my world is in the middle. We manage this developer experience. We have data engineers that manage this. And then we have analysts that work on this side, and they're embedded across the company. So they consume the data that we curate. And then they also contribute to the DBT models themselves. And my team builds sort of on this side of the spectrum. And of course, we make sure that these connections are working, that they're reliable every day. If there's errors, that we have to take care of that. And we add features every week just to make sure that it's meeting the needs of our consumers. So now to Renan.
Hi, everyone. I'm data engineer here at Miro, working with Rochelle. So yeah, this is our workflow, like she was saying. And mostly this is split in different DBT projects, right? So if you see source products, data vault, and warehouse analytics, each one of them are different DBT projects. Our main one right now that have more than 3,000 is the analytics one. And everything is connected, like it's being triggered and orchestrated by Airflow. It's connected to Data Hub, and so every execution, every time DBT runs, sends data to Data Hub so everyone can look. And then Looker is consuming almost everything, like from the analytics to segmentation, experimentation. We provide this data, but the main goal of the talk is actually explain how developers are working on this. So we are mainly use GitHub and GitHub Actions to take care of it. It's a mono repo, so all the DBT projects resides in the same repository. We use dev containers, so just to make it easier, because like Rochelle mentioned, we are working with a lot of people from different areas. We have analysts, we have software engineers, we have data engineers, and we have some other people from other areas that also help us or try to work with it. Then we try to make it as easy as possible for them to onboard and start using. So with the dev container, we have the user config. So the only thing that you need to do to actually start working with DBT and all the stack that we have is define your user and your configs. We provide pre-installed extensions. Right now, we are using mostly GitHub Copilot to help you to write your SQL or write your code. We also provide a DBT power user, so you can go through the lineage and easily find the connections and the lineage between the models. And we have an internal tooling as well. We provide a few ones, but the compare is the most used one for now. And yeah, so explaining how we provide the environment for them to start working. So the production, like Rochelle said, we have huge tables, a lot of tables everywhere. And it was quite hard for people to actually change one model, apply in production, see how it's going. So what we are doing, we are cloning production to our dev environment. So every user or every developer have their own dev database, which is a clone from production. We are using Snowflake zero clone copy. So it takes like almost 4 minutes to clone the whole thing in production. Then whenever you change something, you can run locally, you can check you can validate the data and see the numbers, see if everything's okay. And I think DuckDB could easily reside somewhere here when we are doing some local testing and local development. But unfortunately, we are not using it yet. And then we also have this clone works weekly or daily. You can define how you want your database to be cloned, or you can also use GitHub Actions to do a manual trigger. So let's say I finished working on something, I want to reset my database and get everything from production. I can just go to GitHub Actions and clone my database and start working a new task, something like this. This is the compare tool that we have. So this one, you can easily, from your dev environment, you can run a model, check with everything, how everything changed. Then you ask it to compare with production. So it's going to give you some details like the column that you changed, what happened, if it was removed or unchanged, or if you add a new column. Then you have the deltas from comparing from production to development, and also the percentage of difference that you have in the count. So this is just, we try to make everything easier for the developer to find what changed. And if he's breaking something, let's say you are adding a new column and want to check how many values you have in there, or if you change a value for something, what changed and what's the change. So this is one of the tools that we try to provide with the dev containers and the environment. Besides those tools, we also have a few things that we try to use to help us, like maintainers of the repository, to do some checks. So the first one, we have the CI database. The CI database is just a clone from production, but without data. So we are just compiling all the models and testing if the schema is right. So we are not checking data, we are not running data, because this would cost a lot. Because every time you change, let's say, a table with 100 of gigabytes, it would cost a lot, because every time you push, the CI will run, right? So we are testing mostly if the definition of the table and the query and everything, and if models downstream is not breaking. So if I change one table, remove one column, the downstream would be checked as well, as you can check the field for the multiplied +2. So it's going to leverage downstream to check if you didn't break anything. So that's the idea for the CI. And besides that, we also have a few other PR checks that was custom made. So mostly, if the model have description, if the model have tests, model have the priorities. So right now, what we do to split these executions and to orchestrate the execution is that we have priorities, right? So a model can have from P1 to P5 priorities, starting with P1 with the most important, and P5 is the least. And then you need to define where your model is sit in there. So we trigger from P1 to P5 when we are orchestrating. And then that's how we define the priority for who is working with it and who is taking care. Let's say in this case, the on-call engineer, that who need to be careful and check if everything is running as expected. So it's based on the model priority. And then this tool also checks if the P3 model is not depending on a P5 model. So you can't open a PR and do some different order of the dependency. And also for us to help us, like the business owner of the model. So I'm creating a new model, I put my name in there. If this one fails, it's quite easy for us to find, Renan, who changed this. So I'm going to talk to him to see if he can help me to fix. And also, if it's available, the unique key, right? Because every time we see a lot of duplicates, and this is how we try to help us as maintainers to do some basic checks whenever someone opens a PR. And we were talking about data hubs before, like how we connect and how we send everything. So we also have a bot that actually goes through the models that were changed, goes to Data Hub API, and get all the dependencies. So if you change a model on DBT, it will show you that this model is being used in a few Looker views, and also this model is being used by another model. So this, you can easily see if you are touching something and it's going to break, or if you're changing a value for a Looker view or something like this, then you can check on Looker to see if your change will keep the dashboard working as expected, or just validate the data that you have in there. And then that's how we do the continuous deploy. So whenever a PR is merged, we apply this in production. So we are not we don't stop everything and do a deploy. We just deploy this in production, and the person who's actually merging it is responsible for taking care of the deploy. We have a few alerts to Obscene and also alerts in our Slack channel where we notify if something fails. And then you can also do a manual deploy. You can trigger the manual deploy from GitHub Actions as well. So let's say my model failed, I fixed it, I need to do a full refresh. I can manually deploy it using GitHub Actions and do a full refresh for that one, and everything should be good. So every time we deploy, we clone the data from production to CI main, and then the next PR would have the fresh data, the fresh database information, or at least the DDL for the tables. So the next PR will just check the difference from your PR and the main base, or the production database. And yeah, so this is our team. We are around 10 people working between data analysts, analytics engineers.
Quite a few of my team are here tonight, so you have questions about any of the content. Anyone in this picture is fair game. You can harass them, ask them questions.
Yeah, I think that's it. And yeah, thank you. I'm not sure if we have time for...
Thanks for the nice talk. So one question I have is, one of the things that people do with DuckDB is integrated with DPD, and one of the use cases for that is for local development. Are you guys considering doing it, trying to do it, tried and it didn't work out? Like, whoa.
Yeah, I played around with it one weekend, and we use a few packages in dbt that aren't keeping up to date with database adapters. So those packages use Snowflake-specific functions, or only Snowflake and BigQuery, and they didn't support DuckDB. And then because they're in the package, it just immediately failed. So we basically have to either update those packages or deprecate those packages in order to do it. But that's definitely on our radar, especially for the CI, because we currently run no data tests in CI. But it would be massively powerful if we could run data tests in CI and not run up our Snowflake bill.
Thank you for presentation. Could you go back to your architecture overview? Yeah, and do you use a DuckDB? And if yes, how? No? Okay, thank you.
I know we're presenting at a DuckDB meetup, but we're not currently using DuckDB. So, but that's why we're happy to talk to any of you who are using it to get ideas on what's worked, what hasn't worked.
Cool. Any more questions from the audience? Yes.
Just out of curiosity, out of the you presented that you have 3,000 dbt models. How do you orchestrate them? I mean, how long does it take a dbt build to run? Or do you run a subset of those 3,000 model? Or
yeah, we kind of orchestrate. Let me see if I have it here. Yeah, so these are, each of these blocks are different Airflow decks, right? And each of one of them have their own priority definition. So it goes from left to right, start with source products, go to data vault, warehouse, analytics, and everything. When you are building it for the 3,000, it takes like 2 minutes or so to parse everything and to compile, and then to start triggering. But the whole analytics pipeline will take,
I don't know, like 6 hours.
Yeah, it's a daily batch, right? It's a daily basis. So every day we do the whole process from the beginning to the end. And it takes like just the analytics one, which is the most important one, takes around 6 hours to go through everything. But the most important part takes like 2 hours, which is the P2 ones that we kind of take care of very close. Yeah, yeah, we managed to try to have at least the P2 ones, at least before the day starts in Amsterdam, like between 8 and 9. So everyone starts with the fresh data, and the looks dashboards and everything is fresh enough for them to actually start working.
Thank you. Thank you. Any other questions? Yes.
I was wondering about the Snowflake build. Are you not the exact amount, but are you doing specific optimizations to bring down the Snowflake bill?
Yes. I mean, you saw the little Databricks icon right somewhere over there. We're transitioning to Iceberg for some things. We have figured out partitioning to heaven and back on some of those event tables. We work very closely with the Looker team to make sure that we're optimizing workloads across those, to make sure we don't materialize more than we need to and materializing when we need to if it's a heavy BI load. And we're also trying to not, duplicate data where possible. So like that 217 terabyte table, we don't want 8 of those. Right, we want a few of them, but sometimes Snowflake doesn't deal well with a lot of views in a row either. So you're kind of like constantly whack-a-mole on which performance you care about, and then you have to compare the daily execution versus the BI performance versus the user experience. Yeah, so it's a constant battle for sure.
Okay, thank you. Yeah, you said views on views of views, because if you do DBT without that, then you would be copying data around like crazy. But you're aware of that. Yeah.
Oh, it's a little bit of both.
Recording stopped.